Hello everyone, thank you. My name is Eric. I'm an iOS developer here at Blendle. And I'll be giving a presentation about Texture. It's a framework that's formerly known as AsyncDisplayKit. Does anyone know it? Yes. Has anyone used it? Okay, good. I'm going to give an introduction, so in a way that's a good thing. Texture was created in 2014 at Facebook. They were developing an app called Paper, which had in which they tried a new approach with the UI for the Facebook app. It had a very complex UI with a lot of animations, a lot of interactivity, and they struggled to make it performant, to keep everything smooth and responsive. So they built a framework to be able to offload all the layout measurements and rendering to background threads to keep the main thread to avoid doing work on the main thread. The Paper app has been killed a couple of months ago, I think, but it's still used by Facebook in instant articles, which is a feature in the Facebook app where you can read articles and which works really nicely. The project is not maintained by Facebook anymore. It's currently maintained by a team from Pinterest. They rebuilt their entire app using Texture, and they moved. Officially, it's maintained by a non-profit organization, but most of the maintainers work at Pinterest. Well, as I said, the original goal of Texture was to create a framework which provided a convenient and easy way to do asynchronous layout and rendering. Since then, since 2014, the framework has seen a lot of development, and the goal it still provides a way to do a lot of asynchronous layout and rendering, but it's also grown into a lot more. I will start with a small overview of the framework, the basics, and then I'll talk about its declarative approach to layout code. Blendle adopted the framework shortly after it was published in late 2014. On that side you see the reader in our app. So when you open an article, you go to the reader. This involves a lot of text sizing and rendering. Each provider, like each publisher, has his own style in our app, so everything gets generated on the fly. To keep this performant and to keep the app responsive while all of this is being calculated and rendered, we adopted AsyncDisplayKit, so that all the text measurement and rendering could be done asynchronously. Since then, we've started using it in a lot of different places in our app, most notably in the feeds. When you open the app, you see a lot of cards with articles. That's all done with AsyncDisplayKit. And we use it in every place where it would be difficult, if not impossible, to achieve good performance with the complex UI that we have. We always want to achieve 60 frames per second to keep everything smooth. So wherever it's necessary, we use AsyncDisplayKit. The basis of the framework is the node. In code, it's called AsyncDisplayNote. And it's basically a thread-safe abstraction over UI view. So a node manages a layer or a view depending on its configuration. Nodes themselves are very lightweight. They're very cheap to create, and they're much cheaper to create and handle than UI views or CA layers. It manages its own UI view and CA layer and does that in a very intelligent way. It also has a lot of features that are called range intelligence. So you can tell a node that it doesn't need to create its view yet, but it needs to start fetching data that's necessary to create the view. So for example, if you want to load an image, you can say, well, you're in a range right now where you might start fetching the image if it's necessary, so it will have the image when it has to go on screen. AsyncDisplayNote, and actually the whole framework is very similar to UI View and UI Kit. It strives to retain the simplicity of UI Kit And so the interfaces are kept as similar as possible. So as a short example, if you create a node, just like if you would call its initializer, you can set the background color, opacity. The interfaces of the node are kept very similar to UI view and CA layer. And there's no arbitrary divergence from UIKit. That makes it possible to mix and match nodes and views and layers in the same code file, and makes it very easily. Lastly, but very importantly, an AsyncDisplayNote is completely thread safe and concurrent, so it's safe to use it on different threads. Like I said, this is a small code example of initializing a node. This is provided as a convenience category on UI view, so you can add a subnode to a UI view or to a layer. The framework provides several implementations of subclasses of AsyncDisplayNote. They mirror a lot of objects that you find in UIKit. For example, an AS control node. Well, you all know UI control probably. AS image node is the counterpart of image view with a complete custom implementation for image rendering. It has a lot of nice extra features like animated GIF support. It can also you can also set modification blocks on it. So if you want to round the image, you can do that using an image modification block. You can also provide a tint color for an image if you have a templated image. A subclass of the image node is AS network image node, which you can basically give a URL and it will start fetching an image if it's necessary. It also handles a lot of automated caching, but you can also very easily hook up your own custom caching implementation. And there's also a lot of other components. Some wrap UIKit components, for example, AS edible text node and map node wrap UIKit components, but AS text node and AS image node are completely custom. AsyncDisplayKit also has a custom text engine, which allows for a lot of all the text layout and rendering done on a background thread. AsyncDisplayKit provides asynchronous rendering. You don't need to do anything for this. An AsyncDisplayNote has its own CA layer subclass called async layer. And when display is called on that layer, it will use its custom rendering engine, which can choose to either do it synchronously or render the content of the layer asynchronously and update the contents when it's ready. You don't need to configure anything for this, you just get this on the fly. AsyncDisplayKit, where it really starts to stand out, is in its layout systems. Originally, it was it only had manual layout. This is very similar to the way it's done in UIKit. So normally you have size that fits and layout subviews. In AsyncDisplayKit, you have calculate size that fits and layout. These are very similar to UIKit. And there's not much difference except for the fact that they need to be thread safe because, well, one of the main selling points is that you can do everything on the background thread. So these methods can and will be called on background threads. So they need to be thread safe, their implementations. After a while, when the framework was in active development, declarative layout system was added. Who knows ComponentKit? Yes. It's a framework, for those who don't know it, it's a Facebook framework, also made by Facebook for their timeline. And this is a completely declarative layout system. And what they did is they lifted parts from it and implemented that in AsyncDisplayKit. And they built a layout system that was inspired by the CSS Flexbox system. Who knows that? Ah, good, a lot of people. It's basically a way to describe your layout. So you can say, I have three items and I want to put them in a stack with this spacing, and you don't you don't write the code in an imperative way, like you say, well, this frame and it needs to have that size, but you describe a layout by saying, I want to have it in a stack, or I want to lay it out behind this node. So that's how the system works in AsyncDisplayKit. For this, they created a layout spec. A layout spec in Texture is an immutable specification of your layout. Like I said, it's declarative, so you express your layout in terms of I want a stack, or I want it to lay it out over this node, but you don't write this frame has to have this value, this size, this origin. It's all declarative. This makes them a pure expression of your layout. They're not dependent on any size. They can just adjust. They encapsulate a lot of boilerplate, so they can adjust to any size, to any screen they're shown on. So if you're on an iPad or an iPhone, it doesn't really matter. It will scale automatically. I'll give you an example. This is a node that we use in our app. On that side, you see the reader. And when you don't have a paid subscription to our service, you will see that advertisement in the reader. It has a title, subtitle, and a button. And there's a background node that draws this branding shape. So it has a background color and then a branding shape that's rotated. This is the layout spec for it. We'll go through it on the next slides. Compared to the manual layout system, with a manual layout system, you implement calculate size that fits to return the size of your node, and you implement layout to actually set the layout. With layout specs, you only implement this method, layout spec that fits, and you create a layout spec for your node, and you return that. So, as you can see, we have the title, subtitle, and the button. And we create a stack layout specification. We add those three items as children, and we do some configuration. So it has to be a vertical stack, there's no spacing, and justify content and align items. I won't go into all the configuration details. If you want to use it, there's a lot of configuration options. Be sure to check it out. We have the stack, and then we apply insets. We say, well, we don't care how big it's going to be, but there has to be at least a minimum amount of size on the left side, right side, bottom, and top side. And we add the stack layout spec as a child of the inset layout spec. And then we say, well, we want the branding shape to be visible behind the two title, subtitle, and the button. So we add the inset layout spec as a child of the background layout spec. This way we've created a hierarchy of layout specs that contain the nodes. So it's like you have a background layout spec with a background node, and that has as a child the inset layout spec, and that has as a child the stack layout spec. This is called on a background thread, and what AsyncDisplayKit does during the layout pass, that layout spec that fits method is called, and it builds a layout tree. This is all on the background thread, and it starts to measure and calculate everything. And the moment you actually need to lay out your nodes, it has all the information it needs, so it doesn't have to do any calculation. It can just set the frames on all the nodes, and that's the only work that's being done on the main thread. So you see now that Texture has two approaches. The original one, manual layout, which is very similar to UIKit, and that was originally the only one that was available. Since then, layout specs have been added, which provide a declarative way to write your layout. The declarative way is preferred, but AsyncDisplayKit doesn't force you to use it. It still allows you to define things in an imperative way if you want that, but you can also, the philosophy of Texture is that you can do it in a declarative way, but it won't hide the imperative way. So the declarative way is preferred because you can express your intent and they can derive it. You get a lot of extras. So, for example, normally when you have a view, you add a view, you add a lot of subviews. When you use a layout spec, you don't need to do that. It will the framework will derive from your layout spec which nodes are necessary, and it will add those. And when you change something, you can call set needs layout, and it will do new layout pass, and it will see if anything has changed, and it will remove nodes that are not necessary, and it will add subnodes that are necessary in the new situation. So the philosophy of texture is called hybrid-declarative layout. That's a very nice buzzword, if you ask me. And basically the philosophy is that you want to have the simplicity of declarative layout, but you don't want to give up the control of imperative programming that you have. So they give you the option of expressing your intent, so you don't need to write instructions in an imperative way, like say it has to be this frame, but they won't hide the imperative way. So you keep imperative control, but you get declarative simplicity. So reusable layouts, it will control the complexity of your layouts, and it's very easy to mix both styles. So there's currently quite a few options on iOS to build declarative layouts. I think, well, you have ComponentKit, there's also something called Layout. I think there's also a bunch of others, but texture doesn't force you, and I must say in practice I really like that, to be able to not hide the normal way of working on iOS, but still have access to a declarative layout system that's fully featured and very powerful. So I will give you another example of how the declarative layout system works. This is a card we use in our timeline. So when you open the app, you see a bunch of cards with from articles that you can read. On the right side, you see it looks a bit weird now. This is still work in progress. We're working on a big update in timeline. I had to say this from my designer, so I couldn't show it otherwise. But on the right side, you see a card that is loaded, and this is the loading state. That's also still work in progress, and there has to be animations, but you get the idea. So what we do, this is the layout spec for that card. I won't go through all of it, but what's most importantly is that when the app opens, we fetch all the data, and we initially know that there's a card, but we don't have the data for that card yet. So we create a card without an article, and at that point it's in the state that it's loading. So there's a layout pass, and we check, well, is it loaded? If it's not, and in the initial state it's not loaded, we only take the background node, and we add the loading state node as a child to the background layout spec, and we return that. So that's when you get the loading state node that you saw. Then at one point the data comes in, and we have the data, and we say to the view model, hey, it's updated. And then we trigger a transition. Texture has a built-in transition system for when you use layout specs. You can still, if you use layout specs or manual layout either, you can also, like normal animation systems for iOS just work the same thing, because you have access to the view and the layer, so there's nothing different there. But if you use layout specs, you also have access to this transition layout. By default, it will do a new layout pass. So in our situation, it would say, oh, well, the data is loaded. I want the full layout spec for a card that is loaded. And it will compare the current layout spec with the new layout spec, see which nodes need to be added and removed. And it will automatically do a fade animation. If you want to do your own animation, it will do a layout pass. And then it will say, well, do your custom animation, and you can implement the custom animation, and it will still handle all the subnode management for you. So this is this is the second layout pass where the card is loaded, and you return the layout spec for the full card. Basically, we construct the header and bottom spec somewhere else, and then we put it in a stack spec, apply insets, and lay out the background node behind it, in short. So that's, in short, the layout system. Like I said, we've been using it for, I think, 2.5 years now. I've personally used the framework since the start. I really like this approach. It still allows you to do things the UIKit way with a lot of benefits from asynchronous rendering and layout, but it also provides you with a very powerful decorative layout system. The framework comes with a lot of other goodies and cool stuff. I'll highlight some stuff, but there's really too much to put in a presentation. In UIKit we have UI collection view, UI table view. I'm sure you're all familiar with them. AsyncDisplayKit has counterparts, so as collection node, as table node. What the main benefits of these things is that they will do all the node management for you. So they have intelligent preloading. So, like I explained, a display node is aware of its. You can notify a node of its range. So you can say, well, you're on screen, you're in a data fetching range, you're in a pre-rendering range, and these nodes all work with that. So if you have an AS collection node and you have 100 cells, some of them will be in the display range, some will be in the pre-render range, some will be in the data fetching range, and some will be in the nothing range, or they'll exist but they don't do anything yet, and they're very cheap to use. So they all automatically use range functionality, and they also ensure that all work is done asynchronously. So measurement, data fetching, decoding, and rendering is all done on background threads. So you don't need to think about that, and they work very similar. So AS collection node works in a very similar way as UI collection view. It has the same data source methods, the same delegate methods, and some added stuff. So you get a lot of that without a lot of views, and if you know how to work with UIKit, you know how to work with these things. Some other cool stuff. Sometimes you are in a situation where you've built something with a view, but you think, well, I don't need any touches on this, and for performance reasons, I want to use a layer instead of a view. You need to rewrite your code, or when you start out with just a layer and you need a view, AsyncDisplayNote's provider property is layer backed. When this is set to true, it will only create a layer, and that's it. You can still use the AsyncDisplayNote as an interface to configure everything, the background color, I don't know what, frame, but when it needs to be shown, it will create a layer instead of a view. So that's a very easy way to switch between the two. Secondly, it also provides subtree rasterization. So CA layer has support for rasterization, so it can write, but what AsyncDisplayKit can do is that it can rasterize an entire view hierarchy. So if you have a node with 3 subnodes and you enable subtree rasterization, it will draw all the node and its subnodes in one CA layer backing store. So you don't have multiple backing stores, and for example, the card that I showed that we use in our timeline, when it's shown to the user, that's basically one image, and that's it. There's no composition, no blending done. It's just one image that's in memory, and there's the GPU doesn't have to do anything else. I think there's one button on the card, and that's like a UI view, but the rest is just one image drawn in one backing store. So at runtime, there's no compositing and blending that needs to be done by the GPU. That's really nice, and you don't need to do a lot for that. You just enable it. The third feature is something called run loop impact distribution. Honestly, I'd never heard of it until they implemented it, but it's really cool. Basically, what they do, with texture, you're always doing a lot of preloading. So when you have a collection view, you're creating the nodes way in advance. You're doing a lot of decoding, rendering, data fetching is all done in advance. So the benefit is that there's less hurry. Like when you're doing everything instantaneous, like with UIKit, everything has to be done as fast as possible. But when you're preloading a lot of stuff, the stuff that gets preloaded and pre-rendered and pre-fetched it still needs to happen fast, but because of that, they can divide the work in smaller chunks, and that has as a result, when they send it to the run loop, instead of big packages of work, they divide it up in very small packages, which allows the run loop to run more frequently. And as a result of that, it can check more frequently if a user has done a touch on the screen. So it becomes more responsive, because the run loop checks every time it runs, it checks if there has been a touch, and because they divide all the work in smaller chunks, it runs more often and it's not busy all the time. This is something that you don't need to do anything for. Honestly, I think quite a few users don't even know it exists, but it's helping them keep their app responsive. Yeah, that's basically my short overview of Texture. They have their own website with a lot of resources, talks, explainers of all the stuff that goes on. Very good documentation. It's very actively maintained. The screenshots you see in the bottom are all example apps that have been made for the project. There's a sort of Instagram clone. You see your waterfall layout. Check it out if you want to play with it. It works really nice, and if you work with UIKit, you can adopt this really, really easily and check it out without a lot of changes to your code base. Thank you.
So, are there any questions?
Is this on? Yeah. At what level can I integrate texture into my app? Do I need to use this AS view controller that was briefly on screen, or can I decide to just have one view?
Yeah, you can. Well, you can use AS view controller, but if you have a view where you have a button or a label, you can just have the whole, your normal code. You have subviews and buttons, and you can add a subnode just almost in the same way as you would use a view. In some situations, it's basically when you create the variable or the property, it's instead of a view, you call the constructor of a ASDisplayNote, and that's almost the only change. And you call add subnode instead of add subview, but that's it. You can really easily mix and match it with UIKit components.
Okay. So why do these parallel components exist?
You mean like
view controller and the table view controller?
Well, if you would use it like I just described with just a normal UIKit component and then add one subnode, there's not a lot of benefit. If you have a AS networked image node, you can set the URL and it will automatically fetch the image, so you don't need to worry about that. That's an advantage, but you won't take a lot of advantage of any asynchronous rendering and layout. And when then you'd have to write it yourself. So when so you'd have to spawn a background thread and do the measurement on a background thread. But if you use an AS view controller or an AS collection node, they will automatically do all the layout and rendering on a background thread. So that's the main advantage. You don't need to think about it when you use those collection nodes. In the Blendle app, we have a lot of custom components that take care of that, because we have a very strict MVVM setup. So we work with a lot of view models. So we don't really use the collection nodes ourselves. I've used it in personal projects, and then it's really nice because you don't have to think about it. Everything will be done on a background thread automatically. But we in the Blendle app we force the background measurement and rendering ourselves. So that's something that you don't need to think about when you use those collection nodes.
Okay, makes sense. Thanks.
Any more questions?
Thank you for the talk. You mentioned ComponentKit.
Mm-hmm.
Can you say why do you prefer AsyncDisplayKit over ComponentKit, or if you do prefer one on top of other?
I've used ComponentKit, I think like 2 years ago, the last time. Well, with ComponentKit, it's have you used it?
Yes.
It's very strict in its approach, right? You write those, you have to use Objective-C++, and then you write your specification of your view of your component, and it has its own peculiar syntax, and you really have to do that in that way. That's the way to do it. It's very different from the way you normally create views you write UI code on iOS. And AsyncDisplayKit is really similar. I mean, like I said, if you would just add a display node instead of a view, it would be mostly changing some names, but that's it. Like, it works from the outside, it almost works the same. And ComponentKit forced you to work in a very different way. And I didn't always like that way. And I also didn't really like using Objective-C++ in my app. I don't mind working on it, using it in a framework, but I didn't really like being forced to use that in my app. But that's a personal preference, and I prefer the way UIKit, prefer the standard way you write UI code, and that flexibility that texture offers compared to ComponentKit.
Any more questions? Okay.
How do you judge the risk to use such a framework for such an important part of your application? Because we've seen examples in the past that such frameworks are seized.
Yeah, it's a good question. Well, we started using it gradually since its start, and especially now, it's really actively maintained. So, of course, there's always a risk that Pinterest is going to say in 2 years, well, we're going to use React Native. I don't know. I hope not. But it's a really popular framework. So yeah, you always have that risk. But yeah, we looked at it and it's still being very actively maintained. So that's it's a risk, but we've looked at the activity and there's a whole community around it. Well, like with most big open source projects. But you also see that aside from the actual maintainers, there's a lot of contributions to that from the outset. Like the ComponentKit, the fact that they lifted code from ComponentKit and built the layout spec system and AS collection node, I think those are really big components that were built by the community. So I think even if the current core maintainers would stop, there's still a very big community that uses it a lot. And I think it's deliberately currently structured like a non-profit organization so that it can always go on. And when Pinterest says, "Well, we don't care anymore," there's still like a separate entity that takes care of it. So I think as open source projects like this go, I think it's a reasonable risk, but you should decide that for yourself.
One little other question. You said you were aiming for 60 frames per second.
Yeah.
Do you hire the bar now with the new iPad Pro?
Well, you have one of us already has an iPad Pro. You've run the app on it?
No, it's 240.
Oh.
It's 240 frames a second.
Yeah.
So good.
Yeah. Our app skills. Oh, okay.
But you're reaching 240?
Yeah, or 500, who knows? But yeah, we'll definitely take a look at that. We haven't really tried it yet.
Thanks for the talk. It was very enlightening. I have a question. One thing that always bothers me when you have some kind of UIKit replacement is how does it deal with things like accessibility, voiceover, things like that, and especially the more complicated cases. Is there support for it?
There's a lot of support for accessibility, yes. Secondly, in a way it's a UIKit replacement, but it also utilizes a lot of UIKit components. So it's an abstraction layer over it. It's not a complete replacement. So you still have access to the views, to the layers. So it's not a complete replacement. But yeah, I know accessibility is completely supported. I think I must honestly confess that we're not where we want to be with our own app when it comes to accessibility. I'm actually seriously working on it, but I know that there's a lot of support for it.
Thanks.
Question, what do you use on Android?
Well, they've just started using Lito. What's it called?
Little.
Lito. I think it's the kind of the same thing. I don't know.
Yeah. Okay. It uses some of the same things like Yoga for the Yoga rendering. But we recently just started with it, and basically to build our feeds, so the distribution and the reset.
But it uses Yoga.
Yeah. It's for I think it's also for web and
iOS.
And,
Used by React Native also.
Yeah.
A long time ago I played with QuickTime Virtual Reality Kit, OpenGL, Core Animation and MetalKit. That's the things I have been playing with. Do you think this will also make a chance in Apple now comes with augmented reality kit? And my focus was more on the OpenGL stuff, but I'm very interested to see if how this fits in that picture or in terms of performance.
I haven't played with, you're specifically talking about ARKit, right?
Right.
I haven't gotten a chance to really play with it yet. Well, this is really tightly integrated with UIKit.
Yeah.
I'm not really familiar how UIKit and ARKit work together.
Okay.
Do they? I don't think so, right?
No, I haven't played with it yet,
Yeah.
the ARKit, but I noticed, especially while playing with the OpenGL, there were quite some issues in the OpenGL rendering kit. And for that reason, maybe that Apple made the Metal kit, which is a
lower level.
level.
Yeah. I don't know how if this works with the ARKit. If I have to guess, I don't think so.
Okay.
This is very tightly integrated with UIKit, so I don't think so. But you could check. Yeah.
Any more questions? Last question. So, when do I need this in terms of speed? Would you say that the Blendle app wouldn't be possible without texture?
Well, it will be possible, but
with the same performance.
Like right now, if you open the article, not with the same performance, no. It's the reason we started initially using it because, it's a long time ago. We don't have videos comparing the two, but it was difficult to achieve that performance when opening the reader, and our feeds with the cards are pretty complex. So it's a long way since we used UIKit for those components. Honestly, it's before I worked here, but yeah, I don't think it will be possible. And I've had personal projects where I came to a point where the UI in my collection views became so complex that even with a lot of optimizations, you'd still had like frame drops and that were noticeable. And that's the point where you can say, well, AsyncDisplayKit to the rescue.
And would you start a new project immediately with texture, or would you start with UIKit and then implement texture when you hit that point with your collection view that is too complex?
That is a tough question. I would have to say no, because I don't like dragging dependencies along just for the fun. But AsyncDisplayKit also offers a lot of extras like AS Network Image Node. The layout spec system works really well. I really like using it. So it's not a good reason to drag such a dependency in. So official answer, no, but maybe. And it also really depends on the project. Yeah.
Okay, thank you very much.